Measurement is a fundamental skill of science. It is important that we understand the basics of it before we move on. If we have an object we're interested in measuring, we will need something to measure it with. Here we have a meter stick that we can measure this fascinating gray block. As you can see, we lined up the beginning at the 0 point. The end comes down somewhere about there. This means we have to estimate a bit of our measurement. If we zoom in, we can see that it's 3.1 and then some centimeters. We know it's not quite 3.2 centimeters, so we have to estimate where it's at. We can see visually that's not quite halfway between, so I decided 0.8 seems reasonable. For every measurement made, there is an estimate. The last digit is always considered your estimated digit. So the length of this object, L, is equal to 3.18 centimeters. But what we're actually saying is it's probably 3.18 centimeters. It could be 3.17, or it could be 3.19 centimeters long. Each one of these measured values is a significant figure. In this case, we have 3 significant figures, or sig figs for short. Keep in mind where sig figs come from when we go into the details about how to make calculations with them. First, I'm going to go over some basic rules regarding significant figures. The first rule: all non-zero digits are significant. A measurement like 1,723 meters would have 4 sig figs. The second rule: leading zeros, or the ones in the front, are not significant. 0.002 grams only has 1 sig fig. Those zeros in the front are just there to tell us how small it is. The third rule is that any zeros that are captured are significant. The number 1701 has 4 sig figs. 0.0201 grams has 1, 2, 3 sig figs. The zeros up front don't count because of rule number 2. Rule number 4 is a little more complicated. Trailing zeros are significant if there is a decimal in play. 0.200 kilograms has 3 sig figs. 2,000 with a decimal meters has 4 sig figs. Be careful, because 2,000 without the decimal only has 1. Think of it as being lazy. You would not write the extra zeros on the right-hand side or the decimal unless there was a significant reason to put it there in the first place. Now there's one more rule to talk about, and it deals with numbers that we are far more certain about. If you count the number of people in a room, there's no uncertainty. We count 10 people. That's not to say that maybe there's 9.5 people, maybe there's 10.4. No, we are certain there are 10 people. The same can be said for definitions. 1 dozen is exactly 12. It's not 11.5 or 12.4. This means that definitions and counted numbers don't play a role when we do calculations, but more on that in a later video.